Okay, let's go ahead and finish off this quiz review. We have a few more equations to solve. The first four kind of look alike, but if you look closer, there is a difference, and I will point that out to you. And there's actually, I notice a difference that I didn't really want to be a difference, so I'll point that out to you as well. So solve each equation, round your answer to the nearest 10,000th. So the difference I don't want you to recognize or think of right now is that the first two have addition and the second two have subtraction. Those will work themselves out no matter what type of question you have. You can use the rules of your logarithms to help you rewrite those or condense that one side. The difference I want you to notice is that on 31 and 32, you have a constant on the right side, whereas on 34 and 35, you have a logarithm on the right side. So 34 and 35 are actually going to be similar to 31, except that you have to do one other step before that. So let's get started with these. Actually, I think I'm just going to do 31 and 34. I'll leave 33 and 35 for you guys to work through. And then 36 maybe I'll do also, and leave 37 because that's similar to 36. The answers are on your classroom account. So let's go. Well, for 32 and 33, specifically 32, because that's the one we're going to do now, we notice that we have log base 5 over here on the left of two different things. Well, if we have log with the same base of something plus log with the same base of something else, we can use the product rule, and we can say, well, this is log base 5 of 9, the argument here, times x minus 1, the argument here, equals 1. So that's what we want to do first. We want to condense the left side, and in fact, if you can condense both sides, you do that. In this case, it's just a 1. You can't condense it anymore. So the step that we're going to do now in this one, which you will also do in 33, is you're going to change to exponential form. And the reason you change to exponential form is because you have this constant over here. So this will be 5 to the first equals 9 times x minus 1. Now, anytime along here you could distribute this 9 times x minus 1. We will do that now. 5 to the first is just 5. If you had 5 squared, you would put 25. But this is just 5 to the first equals 9x minus 9, because we're distributing that 9. Add 9 to both sides. So we get 14 equals 9x. And divide both sides by 9. And you get x is equal to 14/9. And if you want a decimal approximation, you could divide that and get an answer. So that is the value of x. 33 is going to be similar, except here we have a 1. Here you'll have a 3, so it will actually end up being something cubed. We add to the first power, you'll have something cubed. 34 and 35 were different in that they have a logarithm on the left, both sides actually. So what we're going to do, on the left side, we have subtraction, so we're going to condense this to log base 6, and when we have subtraction, we know we can do 3 over 3x equals log base 6 of 50. And now that we have the same logarithm on both sides, we can say the arguments are equal to each other. So 3 over 3x equals 50. First of all, I hope you see that you can just reduce these 3's. So it's 1 over x equals 50. And however you want to solve this, you can cross multiply. There's a couple different ways you can think through it, but if you think of this over 1, we got cross multiplying 50, x equals 1, divide both sides by 50, and you get 1/50. X is 1/50. So that's 34, and then the last one we'll do is 36. These are the ones that have a variable in more than one exponent. I'm going to enlarge this a little bit. Here we don't have two options really. We probably could figure something out, but the best way to do this is simply to take the log of both sides. Log base 10, and again we don't write the 10, just the common log. When we do that, we can use our power property or a power rule where these exponents come out front. So we will write this as the a minus 3 comes out front. So a minus 3, put it in parentheses because you will have to distribute. A minus 3 times the log of 4 equals 2a times the log of 7. I mentioned before there are a couple different ways to do this. You can actually leave the logarithms in there throughout, the log of 4 and log of 7, and solve for a. We are not doing that right now. So we're going to figure out what these two things are equal to. Log of 4 is 0.6021. Log of 7 is 0.8451. And now we're going to solve for a. So we distribute. So 0.6021. And since we did plug in our logarithms and we rounded, realize that does make our answer more of just an approximation. So we're distributing this into both of these. So this is going to be 1.8063. You can check that if you want. So we're doing 3 times 0.6021. And there we have it. Multiply over here. We're going to do 2 times 0.8451. Gives us 1.6902a. So we have the a there. And now we're going to solve. And the rest is pretty simple. So the main idea is when you have an exponential equal to an exponential that are different bases and they can't be written as the same base. This might be a pain, but I'm going to scroll up just to point out or remind you what I'm talking about. Like up here when we did these questions a while back, 16 and 1/4 could be both written as a base 4. Well, we have 4 and 7 here. We can't write them as the same base. So we're just going to finish this off. We will go ahead and subtract 0.6021a from both sides. 0.6021a, which leaves us with negative 1.8063 equals, and we can do 1.609 minus 0.6021. And we get 1.0881 dividing both sides. Sorry, I forgot to put a. .0881. And we'll find what a is when we do that division. So we got negative 1.8063 divided by 1.0881 to give us an answer of negative 1.66, really 00. I'll write them in there so we know that we rounded the 10,000th, but we don't have to have them. And so there's that answer. So if we put a back in there, it would make those two things equal to each other.